All right, everybody. I'm sorry it's 6:30 at night and I'm only just getting to this, but in the workshop this morning, there was a little bit of confusion around components of stress and what these mean, particularly the subscripts associated with them. I think it's possible that in your textbook and in your previous studies, you might have seen, for instance, some normal stresses, sigma x and sigma y and tau. But this morning we introduced a slightly more cumbersome notation. We met, for instance, sigma xx, sigma yy, and tau xy. And naturally, there was a little confusion about what these two subscripts mean and why they're necessary. Now, when you're working only in 2 dimensions, as we have been so far, you can get away with referring to something as sigma x and sigma y and tau. But the moment that you move up into 3 dimensions, or you start dealing with several different types of shear stress at the same time, as we will over the next few weeks, you need to be really specific and careful about your notation so that it's clear to whoever you're writing the problem out for, say the marker of an exam, which component of stress you're talking about. And so this video is going to talk all about those subscripts and what they mean. There's a kind of memory aid that was taught to me by my statics teacher many years ago, eventually my PhD supervisor, which I like. It's for these 2 subscripts, and I might write this as sigma ij to be really general. What does sigma ij mean? Sigma ij means a stress in a plane perpendicular to I, and secondly, in the direction of j. So if I is x, we mean in a plane perpendicular to x, and if j is also x, we mean in the direction of x. So let's work through a few examples of that now and just see what sigma xx, sigma xy, tau xy, and maybe some of the others might mean. I'll draw a coordinate system. So there's 1, 2, 3 axes with an x and a y and a z. All right, excellent. And let's try a couple of these. So maybe to begin with, I'll start with sigma, let's say sigma xx. So I mean on a plane perpendicular to x in the direction of x. So what does that mean? Which plane is perpendicular to x? Well, here is the x vector, right? Here is the x vector. So a plane perpendicular to that, we're talking about this plane here, right? The yz plane. And when I say in the direction of x, a vector in the direction of x, I'm talking about basically this blue vector that I've drawn, right? A vector coming straight out of that plane. Sigma xx is a normal stress coming out of the plane yz, kind of in the direction of x. All of the normal stresses, in fact, work this way. They're basically just aligned with the axes of your coordinate system. Where it starts to get complicated is when you're talking about shear stresses. So let's try a shear stress. What if we say, instead of sigma xx, let's say tau xy. And I'll draw a coordinate system in blue this time maybe so that my shear stress sticks out differently. And I'll rub this out just so there's no confusion. And that coordinate system again is going to be x, y, z. And if I was to draw tau xy on here, I need something which is on a plane perpendicular to x. Again, perpendicular to x is going to be kind of the yz plane and in the direction of y. So rather than coming out of the plane, this will be on the plane and it will be pointed up. Now, think for yourself, what if I had tau yx instead? What would that mean? Well, that would mean, and let me draw it maybe in a different color, that would mean on a plane perpendicular to y. So if a plane is perpendicular to y, then we're talking about this plane down here, the xz plane, and a plane perpendicular to y in the direction of x. So we're talking about this guy just here. Tau yx is this purple guy down here. And as a general rule, you'll probably see shear stresses drawn the way that I've done here with these kind of half arrows, and you'd see normal stresses drawn with the full arrows. All right, just to close this out, let's do one more example. Which one have we missed? We haven't got anything involving z yet. So why don't we do a tau zx, for instance. So now I want a plane perpendicular to z. So a plane perpendicular to z is going to be this plane here, right? The yx plane. And when I say in the direction of x, I mean a shear stress that's pointed that way. So I hope that was helpful. If you find yourself now dealing with a sigma ij, you know that means on a plane perpendicular to I in the direction of j.